And thank you so much for joining in. My name is Nish. I work on the .NET PM team. If you guys know Scott Hanselman, James Montemagno, it's the same team, community team of .NET. We kind of engage and grow .NET community. I specifically focus on something called as .NET architecture, which is .NET/architecture. If you haven't seen that page before, I encourage you to go check that out because we have a ton of amazing content for you to get started building production ready .NET apps. For example, like if you are maybe 10 to 15 years experienced architect who are looking for modernizing your .NET and looking for newer workloads like cloud natives and other things, we have some great documentation on that. Or if someone who's just getting started, does .NET work on Linux, or does it work on Dockers? Does it work on Kubernetes? We have documentation on that. So I kind of manage this .NET/architecture. So I encourage you to check that out and help me build this better for you. So we work with a lot of customers understanding how they build .NET in production, and that's how we gather this feedback and create not just documentation. We also have some really amazing reference samples that you can actually look at it, how these are built in production, and build it for yourself too. All right, let's get started. So let's talk about what are microservices first, and so that everyone gets on the same page. By the way, today's talk, we are going to cover resiliency in microservices, though this is kind of an advanced topic. I like to keep things very simple, so my demos are going to be very simple, easy to understand, and I would like to spend more time, chatting with you guys. If you have questions, feel free to ask, and we can go take the discussion forward from there on, right? All right, let's get started. So let's talk about microservices. What are microservices? I mean, generally speaking, microservices is not about taking a service and breaking down into small pieces, right? Or simple web API project or something like that. No, that's not microservice. Microservice is an architectural pattern, right? Where the most important thing is the application is architecture as a collection of smaller services that are focusing on a specific business functionality or defined by something called as bounded context. The advantage that you get with that is they are loosely coupled, so that means they can be independently deployed, they can be scaled when it is needed, and it's focused by smaller teams, and that's the most important aspect of microservices. It's not about just making applications small, but it's also about working on a specific business functionality, and smaller teams can actually focus on that functionality and ship things to production much faster, right? So let's talk about, just to give a comparison of how monolithic applications we used to build, probably in the past or even now, it's totally okay to build monolithic applications. So you basically will have layers, right? So you'll have a database layer, you'll have a service layer, you'll have a web layer. Technically, they are all baked into a single deployable unit, and then they are deployed into probably the VMs. And scalability means scaling of VMs, right? The disadvantage with this approach is that sometimes you just want to scale only part of your services which has more traffic. At that time, you don't have that option. You have to scale multiple VMs itself, and thereby cutting down on the low utilization of resources and that kind of thing. So you basically will be spending more cost doing this. The other disadvantage is you can't ship in production very often because since they're all packaged into a single deployable unit, there will be many teams working on the same product. So you will have to create a release cadence, and you have to keep your bug fixes to the defined cadence and things. You can't really ship to production like, for example, 100 times a day. That's the kind of thing that's happening nowadays. So that's the reason why I put that number there. But when it comes to microservices, because they are split by business boundaries, every team manages its own. So when it goes to deployment, you can obviously use something like containers and orchestrators. So that way, you don't have to worry about where it is deployed. All that you need to tell is okay, I need this much amount of instances running, and they can be scaled to these VMs accordingly, right? So you have those kind of advantages with microservices. Now, one simple question that I want to answer all the time is monolithic bad? Absolutely not. Is it old versus new? I'm sure when I started, I did say how we used to do before, but the reason for that is in today, when you build applications, we are talking about scale, right? We are making use of the cloud. We are thinking about geo replications. We're looking at really large, complex applications. Then these microservices all will make sense. But when it comes to really small teams, small applications, where you can easily manage these kind of deployments, then monolithics are totally fine. It is not about old versus new. It's just about architectural design choice you make, whether you want to build a monolithic or microservices. You can very well start with the monolithic and then eventually migrate it to microservices when absolutely when you need that kind of a scale when it comes to utilizing your resources, VMs, and that kind of things too. All right. So just to give you a brief of what we work on, something called as eShop on containers is one of the most popular reference samples out there. This is a very simple sample, but there is complexity involved in these samples, and the reason for that is when you start designing microservices, as you see on the right side, these are the microservices, so they are defined by business boundaries. So you'll see identity, catalog, ordering, and if you pay attention to something, the databases, they're completely different. So you don't no more have one database and multiple tables, and then having a transaction scope for updating and all those kind of things is gone. You're actually, every independent service is managing its own data, right? And every single service will connect to each other only through the endpoint. So it has to be a REST endpoint or a gRPC endpoint, or some sort of an endpoint for receiving and communicating with data. So that means no two services can access each other's database. The other way of accessing each other is probably through an event bus. Like, you can use something like a RabbitMQ for asynchronous communication, or in production, something like Azure Service Bus. The whole idea is, they have to be completely independent. That means the database, when you split it, you're completely independent from other services. So now you can decide, do you want to have multiple services running? You can even run multiple versions of these APIs in production, and let the API gateway decide what load needs to go to the newer services versus the older service. And then you get a lot of flexibility. But obviously, this flexibility comes with this kind of complexity. And that's why initially I mentioned, you need to talk about, when we talk about microservices, we are talking about the scale, right? So when you have that kind of scale and complexity, then all these things starts making sense. Few examples of other things that we use in microservices, like API composition pattern, like API gateways, and also we implement a variation of API composition called backend for front end, which is like, you have mobile applications, you'll have other web application that is going to connect to this backend. Instead of exposing every single service outside to the world, we expose only the gateways. So that way, the connection, when it is made to the services, these gateways are smart enough to identify what is the kind of request that's coming in, and it can make multiple service calls to these and aggregate the response and send it back. So you also bring in this kind of, flexibility into the picture. And then, of course, there are so many other things like admin services, things for observability and logging and that kind of things. So yeah, of course, there is complexity, but then there's a lot more. I encourage you to check this out, .NET Architecture, or github.com/.NET-architecture. These samples are out there. They're easy to get started. But once you start exploring it slowly, you'll start getting the whole picture of it. But again, don't get intimidated by all these architecturals and designs and other things, because this exists when it comes to complexity. So when it comes to microservices, independent teams are going to focus only on their service. So once you establish this, then probably you are just a catalog team, just shipping catalog, right? So you may not be involved in this kind of complexities at all, right? So so having said that, let's talk about resiliency in microservices. Now, there are many things when it comes to resiliency. For example, the moment you start thinking about cloud, and the moment you talk about complexity, you have to be ready for failures, right? There could be multiple failures that can happen when we are interacting with multiple services, right? So it's not about avoiding failures, it's about being prepared for a failure. So that's what we will talk about in managing resiliency. Now, there are many things like implementing health checks, implementing observability, and all those things. But there are two things that I want to focus on today, and that is two patterns. One is the retry and the circuit breaker. And we'll start looking at it, how to implement those things in code. And we'll also look at how to implement using infrastructure as well, using service mesh like Linkerd, right? So now here's the example that I was talking about. You have the API gateway. There is a mobile connection, there's a client connections, and then there's a MVC app, which is all connecting to the API gateway. Now you can see that every call that is made, this gateway has to be up, and then the gateway will be calling multiple services behind the scenes. So they all have to be up. Probably microservice 1 may communicate with microservice 2, who knows? In that case, if there is an error there, then we will have a cascading failures. So how do you be prepared for such a failure, right? And these failures, I'm talking about transient failures, which is like, it doesn't happen all the time. It just happens, sometimes it just happens in between. Then how do you handle this gracefully, right? So that is, for example, here's the things, right? You have to implement resilient communication everywhere where the service is doing inter-service communications, right? So then you go ahead and implement something called as retry. That's a pattern, which we'll look at it little detail. And then you do an exponential backend, because when you try retrying, I mean, as the name suggests, the retry is basically you try to connect. Let's say a request comes to the client MVC, API gateway receives it, but unfortunately the microservices one is unavailable. So what would you do? So it'll try and make a request. It is not able to communicate with each other. So it'll do a retry. So it is failing. It'll do a second retry. It is again failing. But if you keep doing retry every second, the chances for denial of service, right? Because your servers can't take that kind of load. I mean, imagine when the service is down, you're not talking about single application connecting to this gateway. You will have hundreds and thousands of clients trying to connect at the same time, and then the microservice is down, right? So what would you do? So you don't want to retry immediately. So you will implement something called as an exponential backoff, which is like, provide some logic to don't retry immediately, but provide some kind of logic to go, okay, I'm retrying at 2 seconds. Now the next time I'll go exponential, I'll go at 4, 6, 8, depends on whatever logic you want to add. And also when it comes to cloud, it's also nice to add some jitter logics to avoid all those kind of even the adding more exponential stuff. All right, I think I went down. Just give me 1 second. Okay, so the third retry, when it's successful, it just makes a success. So when you do this, the client application is actually waiting on this. So that way, you're not breaking it immediately, but you're just waiting to see if the microservices can come up immediately. And this is a very typical scenario in a Kubernetes environment, where services may go down because Kubernetes is trying to move the parts around, right? Something goes wrong, they're just trying to bring up the thing. So it's a transient error. So it will come up very soon. So you just don't want to lose the client at that time. So you will hold and do the retry. And I think we talked about the exponential backoff. And the other another pattern that we would add to this is to do something like a circuit breaker. So you do a retry, you do second retry, and the third retry, and the fourth retry, we'll do an open circuit, which means once you define a policy that, okay, after third retries, I don't want to hit again, so I want to keep an open circuit. So remember, when you're implementing this, you're also very, very careful about your infrastructure. You're not overloading the infrastructure with these things, right? So you will keep an open circuit, which means just go by the electronic circuit format where circuit is closed and circuit is open, right? So when it's open, you will immediately get the exception, and no more retries will be done. So that way you can actually decide what you want to do during an open circuit. One simple example you probably want to see, not just open circuit, but just handling resiliency, is you might be shopping on some of the e-commerce site. When the payment gateway failed, they'll tell you, okay, we will try this again and we'll get back to you. They don't fail it, right? They just don't go fail it and say like, okay, everything is gone, retry this and things like that. But they say, okay, we're going to retry this after some time, and then later they'll tell you if they have failed permanently, or they want you to do it again, or whatever, or maybe there was a success, right? So these kind of things can be implemented using these kind of nice policies out there. Okay. So today, what we're going to do is we're going to do some demos, which is building microservices in .NET. I want to introduce you to something called Thai, which is a really nice tool for building microservices. As a developer, it just makes it easy to build with multiple services. So we'll look at a sample of that. Then we'll take a look at implementing code-based resiliency using Poly, all these circuit breaker and retry logic that I was talking about. We'll go and see how to implement this in .NET, right? The second thing is we will take one step forward. We'll remove everything from the .NET, and we will try and implement this in infrastructure-based resiliency, which is using something like a service mesh when you are implementing in Kubernetes. So we will take a look at that also. And then in the last, I'll leave you with some self-learn module, which is like a free. You can use Azure CLI to learn everything. All that you need is an Azure resource. So I'll show you how to get started with that too. Okay, so let's get started with the demo. So here I am. I'm in this microservices folder. If I just list it, you'll see there are two services like backend and frontend. Let me open this in VS Code here. So you can see there's a backend, there's a weather forecast controller. I mean, this is something when you do .NET new web API, this is by default whatever gives you, right? Some random weather data every second when every time you make a call, it just gives you some random data as a weather service, right? So that's it. That's a backend. What I did is I went ahead and created some UI as well for that to see. Let me take this service and web service and connect to this backend service, which is the weather, and display it in the UI. So there's no rocket science here. So if I want to run this, I'll just go to cd backend and say .NET run, And now it's going to run on Finance 00 port, Finance 01 in HTTPS. Now I'll go to the front end and then run the front end too. So I'll just do a .NET run. And that's it. So that'll run on Finance 02, Finance 03. So I'm just going to open this. I'm going to bring this here. So there you go. So just a simple UI. Every time I hit it, it just goes and refreshes and have things. Now, did you see the number of steps I took to do this? I had to go to backend. I had to go to frontend to do .NET Run. Now, that is really okay for two services. I can have these tabs open. And if I'm debugging, then it's fine. Then I do an FI and kind of things. But since I'm working with multiple services, all these services have to be up. Wouldn't it be nice if it can all run it together, right? So that's why we built the .NET team specifically built something called a STI for helping you do this in scenarios for development. Okay, so look at this. So what I would do is I'll just say TIE, and that's a tool that it's a global tool that you need to install. TIE and just say run, and that's it. So now what it goes is it's going to build the projects, and as like any other cloud native app, it is going to give you a nice dashboard. I'm going to bring this dashboard here. It seems to be opening on my other monitor. So you can see that it's a nice dashboard. So it's running a backend project. There's a front end project. There's nice ports out there. So if you noticed, there's logs also. So I can go in and see the logs of each of it. And I can also go and see the metrics of these, like, how much garbage collector is working with, and all those kind of performance stuffs is also comes like free with this TIE, right? Now, if I just go and say, okay, that's my front end, and I go and hit the back end, I just open this HTTPS port that was created, and there you go. There's an exception, and that's expected, right? Because what happened is it is trying to look for a port called localhost Finance 01. That's what backend was actually enabled for running. But what TIE did is it did not do that Finance 01 or Finance 02, though you can specify it. But what it did is it just went and looked at what are your available ports in your computer, and it provided a random port, which means now it doesn't know what this backend port is running. So you need to make your code smarter to understand that, right? So let's go and fix that in the code. So for that, what I'm going to do is, so front end is connecting to the backend. So I'll go to the backend, the front end, and go fix that hard-coded value. I'll just remove this and bring in something called as configuration.getServiceURI backend, right? Now this one comes with a configuration extension that comes with the NuGet package called Microsoft.TIE-extension.configuration. All that you need is that. Once you set it up, you're all good to go. And now we can just go and run this and TIE run, and it's just going to work, right? So this time I'm going to do something called as TIE run watch, which means I can keep running the stuff and then use some time to build it as well. So do a dashboard. Now this dashboard comes again. Now I have this front end. I click on it. There you go. It's all working now, right? Now that's a simple service. What if I want to add a data store to this whole thing, right? I mean, every microservice will have its own data store. We spoke about that. So how about let's go and add some data stores. So what I want to do is I want to cache this value, whichever it has been generated right now, like for example, in the controller. I want to cache this value. For that, I'm going to use something called as Redis cache. So I have this code written. So I'm going to uncomment this. I'll explain this code in a bit. So I'm going to comment this random generating code. And let's go take a look at this distributed cache implementation. And now what it does is basically generates a random value, but then it just sets the cache, and it says, okay, for 5 seconds, the cache is valid. Whenever there's expiry of 5 seconds, there will be a new random value generated, right? Now, we talked about like, okay, now we're going to implement, okay, there's a code for implementation of cache, but how do you connect to it? You need a connection string and other things like that, right? Now, if I want to do that, how do I go about doing that, right? So if I go to the startup.cs, okay, before going to that, let me show this back in .cs branch. I have this something called as Microsoft extension.caching.stack exchange Redis. So that's what you need to implement if you want to work with Redis. So add this NuGet package. And then there is a small thing that you need to write, which is the services.add stack exchange Redis. And here you want to provide a connection string. Now you see this, I'm again using something called as connection string and giving a name to it, which is Redis, right? So that means we need to have a connection string, which is with the key Redis, and that should be done, right? So should I just go and install Redis and then create the connection string called Redis and then 6379 used by the default port and then connect it? You don't need to. What you can do is you can simply go ahead and use Thai. You can tell Thai, hey, I need a Stack Exchange Redis and I want to run it. For that, let's see what happens, right? Okay, I can't do this watch anymore. Now, let's go ahead and do Thai init, because you need a configuration to tell Thai that you need some data store, right? So when I do Thai init, it is going to give this Thai.yaml file. So by default, when I was doing Thai run all this time, it was looking at the solution file and looking at, okay, these are .NET projects. So Thai knows how to run the .NET projects. So it did magically done that thing for you. Now we're talking about Redis cache, right? So I have to tell this configuration. So YAML file, this Thai.yaml, think of it like more like a configuration file where you will provide Thai with this information that you need, right? So in this case, what I'm going to do is I'm going to add something called as Redis containers, like images. So this is the configuration that I'm using. So you can see this image Redis. So now I don't have to install any Redis installation in my machine as long as I have Docker running. So it is going to pull this Redis image and it is going to set the port for you at 6379. And it is the name is Redis. So when the connection string is asked, it is going to create Redis colon 637. So for example, here it is connection string. So it is going to create Redis colon 6379. And then your application is going to straightforward work. Let's see if it is going to work, right? So now I'm going to just say Thai and say run. So again, it's going to bring the dashboard in. Now you can see that there is one of the steps that says, okay, now it's going to running image Redis for, right? So it actually pulled the image as well. And it has hosted a container for you. It's running at 6379. Now, if you go open link in new tab, this is an error. This is a deliberate error. I'll show you this error. Now let me refresh it, refresh it, refresh it, refresh it. You see this value is not changing, but after 5 seconds, you'll see that value changing as well. Sorry. So there you go, it got changed. But I think you also noticed there was erroring out in between, because that was my deliberate attempt to create a transient error, right? Creating infrastructure related issues would be harder for me. So I thought, like, I will throw exceptions randomly. So let me show you that so that you don't feel that this is a demo error or something like that. So here you go. So what I'm doing is I'm just creating a random value and saying, throwing exceptions, saying, okay, this system is down. So I want the system to take care of itself. Where is my browser? Come on. Let's refresh this. And go to this 570. So okay, there you go. So sometimes it gets this error system down. So you can also go and check this information inside the logs and other things. You will get the same errors, but you see it like now where the Redis cache is implemented easily, right? So Thai makes that life easy for building microservices. Now, well, I talked about Thai. I talked about Redis. So how did Thai know to run this thing? For that, you have to make sure you're running Docker. So this is my Docker here. So I'll tell you some tips and tricks on Docker too. So if you're installing Docker, please use this use WSL2 base engine. This makes your life much easy because it is going to use the WSL2 as its base engine and then start doing it. So you don't have to explicitly say, I need 4 GB of RAM. You don't have to give those virtualization configurations and other things, because WCL2 takes care of it, and it's just really great. And also for Kubernetes, I use the Kubernetes that comes with Docker. You can use Minikube if you want to, if you're running locally, or you can use Azure CLI and then connect to AKS. You can use Azure Kubernetes Service, but for learning, you just want to keep it simple. So just use this enable Kubernetes, and I'll show you the demos with Kubernetes with this, right? So now everything is running fine, great. So now let's go and implement resiliency. You saw that errors were happening. We want to avoid those errors, like not avoid, like kind of be aware of those errors and kind of handle it gracefully. So let's go and implement that. So go to the Visual Studio Code. So the error, the front end is connecting to the back end. So I will implement it in the front end. So you go to the CS Proj. I have another library, nice library that does this work, which is the Microsoft.extensions.http.poly. Poly is a library that gives you policies that you can apply it on your IHTTP client factory and say, this is my client, and I want these policies to be written in the client. So whenever that client makes a call, these policies are added to it. So there are 2 policies that I'm going to add. One is a retry policy, and then the other is the circuit breaker policies, which we discussed about it, right? So let's go and implement that. So what I do is whenever I'm creating add HTTP client, I'm going to add 2 more lines to it, which is add policy handlers, add policy handler, get retry policy, and get circuit breaker policy. Now these are just my static methods here. What it does is just saying HTTP policy extensions dot handle transient HTTP error. Now we're going to use something called as wait and retry async. So we're going to wait and retry for 5 times, but we don't retry every single second. You can specify it constantly, like, every time just retry, whenever it fails retry, but don't do that, because then you will be hitting the server too. You're going to add load to the other server, and you can probably bring it down for real reasons, right? Or you will get denial of service exceptions, which becomes really harder to go and fix it later. So instead, we go do math power, basically just to give it that exponential back off. So we're going to have some retry attempt, and then we're going to retry, waiting for a few seconds, and then try again. We'll also add one more policy, which is the circuit breaker, right? After 15 retries, we will open the circuit so that no more retries are made, and then it is open for 15 seconds as well. So you basically like wait for half a minute to basically retry or something like that, right? So that's it. Just add these policies, and let's see how this behaves now, right? So now I just go and build Thai run. See what happens. It's going to build projects. It's going to bring in containers, and now it's listening. So let me bring this again. So now if go open link in a new tab, I'll refresh it. I'll refresh it. I'll refresh it. Where did the error go? Now, the error did not go anywhere, but what happens is if you look at this progress bar, watch this progress bar when I refresh it, refresh again, see this? There is a time it is taking to retry it. So under the hood, so you can actually, I can tell you this by just going to the backend, backend, and that's where the exceptions. See this? The exceptions has been throwing system down, but to the end user, it is never seen because it is doing the retries for you magically. And you just kind of build a system which is like never failing, right? But that was great. Now, what we did until now was in the code, which is great, which is like adding policy handlers and other things like this, right? But when you start deploying this in Kubernetes and other things, you may be working with a number of other services too. And those services may or may not be written in .NET. It may be written in other languages. So when these policy handlers, when you define, you probably have to define it for all these services too, right? And that becomes extremely hard to bake in these kind of cross-cutting concerns into your code. And that is why we have another option, which is using infrastructure-based resiliency. And we'll go and see how to implement that, right? So we're going to go to the very next step of doing this. Now, for that, first and foremost is you shouldn't be using this because we don't want two types of retries. It's unnecessary. So I'm just going to get rid of this. I don't need to deploy this there. And what I'm going to do is I'm going to deploy this application into my local Kubernetes because that's where we can start using service mesh and other kind of concepts, right? So let's get this out. Okay, you can ignore this error. It's just a error. Okay, so now if you want to deploy this, let me see this. So backend and frontend, there's thai.yaml file. You can simply go say thai deploy and go into the interactive mode, and then this will go and deploy everything back and front end into your Kubernetes. Now you may be thinking, wait a minute, I know Redis cache is running on containers, but what happens to the backend and front end? Thai was running it as a .NET projects, but the beauty of Thai is that you didn't have to add Docker file to create an image. Thai would do that automatically. And then it'll create the image. And when it goes and deploys into Kubernetes, which I'm going to show you now, I already did this to save some time. So I go to kubectl, get pods, say there's backend and frontend running, right? So when you do thai deploy it is going to ask you a few things like where is your container registry? Because once you make this as an image, it needs to go and store it somewhere so that the Kubernetes can pull it, right? The easiest way to do that is using Docker Hub because it gives a public repository, so you can use that. You can also use ACR if you wish to. or any other container registry for that, wherever it can pull the information or the image, right? So I basically go and use by default, I use the Docker Hub because it's easy to get started and deploy and things. And I don't have any kind of like secured applications to worry about because these are demos. But if you have in your environment, you have secured applications and you want to run it within AKS and other things, please go and use ACR and AKS for these things. Okay, so you also I went and installed some few things like Redis cache, which is what was needed for it to run. Then there's Zipkin. Zipkin is an extension that I added to see the distributed tracing and other things, but I'm not going to demo that today because we don't need to get there now. So now let's run this. For that, what I'm going to do is I'm going to port forward my service called frontend, right? So I'll call this a service and 3000 and internal port is 80. So let me go there. Let me bring the browser in and let's go to localhost 3000. You see that there is the exception. Sorry, there is the page that is running, but I can refresh it and there you go. The error is happening, right? So in production, the error is happening, but the reason why it's not showing you the actual error is because we are running in production, right? So only development environments will give you that exceptions details. So yeah, at once in a while it is having an exception. So let's go and fix it. So now we're going to fix this in infrastructure, right? So to do this, I'm using something called as Linkerd. So let's go to Linkerd. So this is a service mesh. You can go and install Linkerd on your system by just using these commands. The way I do it is I go to the Linkerd release pages. I go ahead and download this exe from here, the Windows one. I put it in a path called C, I think. Again, that's stuck for some reason. C tools. Yeah, there you go, Linkerd. And then I just add it to the path, right? Now, once I do that, what I do is I go and say Linkerd. So this will give you the command. So now you can actually ask Linkerd to check if my Kubernetes is ready for this installation. So you basically use the command called Linkerd check, and I think it is double free. I think it's single. Okay, let's go back to the documentation. I think it's here somewhere. Oh, there you go. Linkerd check -pre. I thought I wrote that. Okay. Uninstall Linkerd control plane. Okay, I was not reading the name expression. So it is having. So I did it already, and that is the reason why. So if I go say kubectl get deployments namespace probably is Linkerd. So I had already installed it, but basically what you do is, again, I don't know if you guys are new to this, I'll also explain this. If I go to configuration and say get context, so this is the kubectl context, right? So this is Docker desktop. This is what it tells the Kubernetes tools to use my cluster, which is the local. Now, if you're working with AKS and other things, your cluster would become the AKS cluster, right? So it will do all those things. So whenever you do anything with Linkerd or any other service mesh that you will start installing, we'll actually look at this context and then deploy it. So be aware of it and don't make that mistake of like you might have multiple clusters. So make sure where the star mark is, and that's your current cluster, and you have to deploy to that, right? So in this case, it's just going to deploy. So you just go through this check and apply, and it'll go and install the Linkerd. What that does is it is going to give you this nice dashboard showing, what are the things that you can mesh it. Now, let me explain a little bit of Linkerd. Okay, these are, I was just telling you about some kind of infra-related stuff. Now, why do you need Linkerd and other things? Is because they're service mesh, the best way to put it is they use something called as sidecar pattern. So your application is running on its own pods, but it'll also have its own separate pods running with your application, which takes care of service-to-service communication, okay? By using proxies and other things. So the advantage that you get is now you can move that code that you wrote in C# in Poly. You don't have to write it in your application because usually your application should focus on business. And now you can actually configure that in a service mesh, saying, okay, how much I want to retry and other things can be configured. So the advantage is now they are service, as I said, it's a sidecar. you can actually put the same policy in a .NET service or a Node.js service. You know that, Kubernetes running, Linux containers. You can have Node.js, Docker, and Java applications all running together in the same cluster. Same infrastructure can be made use of. And when they're working with each other, you can also say, we're using service mesh, you can also define, okay, when these connections are made, this is the retry logic. Or, all the other advantages that you get with this Linkerd service meshes is that it gives you nice observability of looking at, okay, how many services are running and I think so, which is what I'm going to show you next, which is if I go here and say Linkerd dashboard. By the way, you don't have to worry about these things. I have documented all these things. So if you want to try this out later, okay, give me 1 second. I need the dashboard. Okay, there you go. So this is the dashboard that gets created. So you can see this, it's very similar to the Kubernetes dashboard, but it'll tell you that, in your default namespace, let me just go here. The default namespace, that's where I have installed backend and frontend. It says 2 of my services are meshed. And that is why if I just go and say kubectl get pods, you can see that, it's running 3 out of 3 because, it is running 2 of the backends and frontends. But then the third one, which is the sidecar, that is the mesh that is running, right? So that takes care of all the infrastructure and things. Now, how do you mesh this? Now, again, I'll show you how to do that because all that I'm showing you here is on my repository called on.net. So I did a show with Cecil on .NET, and I actually had built a sample for that, and that's why it's here. So I'm using something called as like the service mesh, Linkerd. So there are steps about tie deploy, what it does. You have to provide the configurations, connection strings. If you're using Zipkin, then add the Zipkin configuration as well. And then here's how you go and install Linkerd. Here's a check that you need to do. And once you run it, here's how it'll be. It'll have all those things running. And then go to the dashboard to see this, right? So the next thing that you do is you use these commands for the front end and the back end. And I use something called, and we pipe this command. We actually take the deployment YAML file and pipe it with, and inject Linkerd annotations to it, and then reapply that. So you remember when I did tie deploy, I was not working with any Kubernetes YAML configurations because tie was doing all this magic for me. So I don't have the deployment scripts. So in production, you don't need to do something like this because you probably can annotate it right where your CI systems or CD systems where it is deploying Kubernetes you can write those things. So in this case, I'm not. So I'm actually getting that deploy, whatever is deployed, and I'm injecting Linkerd to it and saying, okay, I want this service to be meshed. And then applying to all these things. So even though I say, okay, you can go and apply for all the 4, services, I'm not doing that. I'm actually in my local, I'm actually meshing only 2 of it. And that is the reason when you go to the Linkerd dashboard, it tells that it's only 2 of the things that is meshed, right? So now if I go to the default inside it, so it gives me these replica sets, the parts, those details, right? Now you see that success rate, there's absolutely no success rate that is given. That's because we have only hit some twice or thrice. So let's go ahead and hit the URL with some more requests so that I get more failures, right? So what I'm going to do is I'm going to use a PowerShell script for that to hit it. So last time I was doing 5,000. So in this case, since I'm doing, I did not expose it, right? I think. So let's put forward 3,000. And I go to the next URL, and instead of 5,000, I'm going to use 3,000 because that's where basically what it is doing is every single second it is going to hit it. And the reason why I wanted to do that is basically I want to show you sometimes there will be failures, and this dashboard will show you, okay, the success rate has now gone down to 33.3%, right? So it tells me, okay, you have some problem in the backend. It is not being able to reach, it's not reachable for some reason, or there's a success issue there, right? So not just this, it can also give you this Grafana dashboard. So if you can go into the Grafana dashboard, get to the home of it, it tells you the success rate of it. It tells you all more details. I mean, these are the things that service meshes come with, right? It gives you observability on how your service is working. So in this case, we only have 3 things that is working, but then in reality, you will have hundreds of microservices working together. So you want to know where the issue is. You want to take action on some when things goes bad and things like that, right? So now let's go fix this, right? We're not going to reduce the success rate. What we're going to do is we're going to fix, so someone who's accessing our application should not be thrown an error all the time. Instead, let's see if we can gracefully handle it. So for that, what I need to do is, go back to my folder. I have something called a service mesh, and you can see that I have both Istio and Linkerd, but Linkerd is one offering of service mesh. There's Istio also. So whatever you like evaluate it, and then you can go and use that. So I have, again, if you go back to my README file, I have also a description about how to do with Istio as well. So if you are someone who wants to do with Istio, there is that too. Okay, so now let's go and do Linkerd. So I go to Linkerd. What I'm going to do is use this kubectl apply command, go to F, that's one file, and say I want to apply backend service profile. Now, before I do that, I want to go to the and show you what is written in there, right? So this is my service profile, and it's very similar to how you write Kubernetes YAML scripts. Here, I want to say that, okay, this is my path weather forecast. If for this, I want something like retriable true. So all that you do is write down in the YAML file saying I want to retry, and the service mesh will take care of retrying it without any issues. Now, remember when we are doing poly, we had this retry, exponential back off, and service breaker, circuit breaker, and things. When you do service mesh, especially in Linkerd, you don't have those kind of concepts. Instead, you have something called a retry budget. It says, okay, I want my retry ratio is 20% of the original request is something what I want. So it's a different way of telling, how to bring down those hits to the backend, right? So I enable this, and now I can apply this. And there you go. It just goes and applies it. Now, if I go back to my page, front end, I guess 3000. Okay, we need to, oops, sorry. Forward. Let's go back here, I think. Okay. So now 3000. Let's go back to localhost 1000. And now I can just refresh it, refresh it, refresh it, refresh it, refresh it, and you'll never see that error. Those errors have gone away. Now, the difference is we did not write it in code. We wrote it in the infrastructure, and that's the key thing about it. Okay, so I think I still have 10 more minutes, so I'll show you a few more stuffs. So in between, let me check if you have any questions for me. Let's say we have two APIs. The .NET API consumes Python API for some processing. How to implement this in microservice and how they should communicate. Python API need not be exposed to client app. Yeah, that's fine, because as I said, so this is how service discovery works, right? Internally, once you define the service, each service will have to be given a name. So if you're, for example, in Kubernetes YAML file, you provide the service name, and that becomes your HTTP : that service name becomes your the place that you want to reach. It doesn't have to be Python. It can be anything, any service, right? The moment you hit it, you have to tell that, obviously, in that Python, you have to say what is the port that you're exposing. For example, H80 is the HTTP port. So if it is exposed, you can actually connect with that easily. So within the service, you can work with other services. Absolutely no issues with that. Are there any other questions? No, for now. Okay, let's go. Okay, so now let me show you how to do this yourself, right? So I encourage you to go check this out called aka.ms/ASP.NET-microservices. So this is something which we built recently, which has a lot of ways to build microservices. For example, the first one says create and deploy a cloud-native ASP.NET Core microservice. The way we design these modules is, you don't have to even have any installation on your system. You just simply click start. You need to have an Azure subscription. If you don't have, just create a free account there. Once you have that, just go into the Azure CLI. All that you need is Azure Cloud Shell, and then just run this thing. Once you do that, what it does is it just goes and creates this whole eShop and containers, whole e-commerce application completely on your cluster or Kubernetes cluster, because we scripted everything. So it's very easy for you to get started. Then what it does is your job here in the first module is basically to create a new service called the coupon service. So you will go and create this coupon service, and in the making of this, you will start learning, okay, how is these services communicating with each other? when a coupon is applied, how does the order service know that that coupon is applied? So that's through your event bus, and how they communicate with each other through API gateway, all those kind of things you will start learning, and now it will start to make sense, right? So your job is to just build coupon service. You don't have to worry about any of this thing. And that's the typical real world of microservices, where you don't worry about the existing clusters and other things. You worry about your service and how you want to implement. And it's your endpoint, right? You receive something, you process something, you let other services know through events, or you'll call their APIs and update it, right? So that is what is there in this module. You can go and learn this in the process. In this module, you'll also learn about health checks. How do you implement health checks in .NET? So that Kubernetes has these two probes, the liveness and readiness probes. You learn about what are those and why you need them, and such things like that, right? So whatever I showed you today, and that, let's go back. And that is there in this one, implement resiliency in cloud native ASP.NET Core microservice. So you can go into this and you can actually start today. I mean, you just need Azure subscription. Just sign up. If you don't have one, just free account, just sign it up and then execute it. So you will learn how to do this in directly in like a production like environment like AKS, right? So you can, it has two options, like, how to use Poly. Of course, you're actually building this in a production like scenario, so you will approach it differently, like, how do you use these coupon applications and other things. It has a lot of explanation, and by end of it you will learn a lot of things. And then you can also have some questions, knowledge check answered, and then there is some kind of like, once you answer these, and then it'll add it to your profile as someone who has completed this, so you can actually pat on the back with these points that you collect here. Okay, so, and then there are more stuffs like instrumentation, feature flags, GitHub actions, and we are actually building some more in the next coming months. So you will see more of it. So make sure that you have this thing bookmarked, ak.ms, ASP.NET-microservices. The other page that I wanted to show you is the .NET architecture page. So here we have some really amazing books. Like, if you are someone who are getting started with microservices, you might also want to look at Dapper for .NET developers, which is something which we recently launched. This book is really amazing. This talks about how to take these cross-cutting concerns that we speak about and take it inside the distributed application runtime framework, right? Or runtime, sorry. And then there is a free PDF. And the good thing about this PDF is you click on it and it just gets downloaded. You really don't have to fill up any forms or any of that sort. We don't need any of your information. It just starts. You can just start reading it right away. And so there you go. So this is the book. This is a free PDF, and you can go and learn this Dapper. You can also learn a lot of other things. Like, for example, one of the things is Microservices Architecture book, which explains a lot of things about how do you design your microservices with CQRS, DDD, and all those kind of concepts. You can also, there is also something called as eShop and containers. This is, as I mentioned, this is one of our popular samples. This is what we use it to show the large complexity, but they are very simple. If you install the Docker correctly with WSL2, you just have to do a Docker compose build and up, and you'll have all these services running in your local system, and then just navigate to the local Docker host and then run it. So if you want to install it in local Kubernetes, you can do that. You want to do it in AKS, you can do that. So all those things are explained in the wiki here. And if you have any issues, you hit some issues, let us know, and we'll be happy to help you out there. And what we want is, we want you to be successful building microservices in .NET. Having said that, let me see if I have anything left out. Nope, I think that's it. I think I've covered all of this. So I think I'm going to give you back 5 minutes of your Saturday, and so that you can go back and enjoy with your family or friends, whatever. And thank you so much for joining in.